Hello again, ladies and gentlemen. In this final video, we're going to look at how to take our parabola with the two x-intercepts and vertex and how to actually derive the final equation for your basketball shot. So, I am in GeoGebra, as I have been, and my points are up there. What I need to do now is I need to work backwards in order to FOIL and then refactor and so on in order to get my final equation. So, I know in this case that my x-intercepts are 2, 0, and 12, 0. And I know that my vertex is sitting in the middle there at 7, 6.5. So what I'm going to do now is I'm going to show you how to work backwards through that. If I work backwards, this is what I get. In here, I have a flip chart already brought up with these two binomials. I have x minus 2 times the quantity x minus 12 because of my x-intercepts. I have them at positive and negative 2. From there, after foiling, we take it down to an x squared minus 14x plus 24. Now, because this whole parabola was negative, technically on the outside here, I could also multiply this by a negative 1, which would give me a negative x squared plus 14x minus 24. Now that's nice and quick. The problem with this, though, is that it is not accurate to the equation that I shot. And I'll show you why. When I pull this back up, I can type in that equation again. And I can type it in using y equals that negative x squared plus 14x and then minus 24. Now watch what happens to my parabola. That will go through the same x-intercepts, but when I hit enter, it's not going through my vertex, and it's not a part of my equation. We have this happen a lot in math, especially with parabolas, because they all are a part of a family. There are many parabolas that actually go through both the 2, 0, and the 12, 0. There are plenty of them. So this is technically incorrect. So I don't want to type that one in. So I'm going to delete that one. I'm going to go back to my flip chart. And here's where I am. Now, I know that this negative 1 is not going to help me, so I'm going to erase all of this. You get rid of all that stuff. And I'm going to rewrite. From here, I need to be able, and I need to know, what the leading coefficient of this term is going to be. We know that this is going to have a y equals because this is actually graphed. It's a parabola, we can graph it. Well, if we remember, if we look back to when we actually worked with the quadratic formula, we used a long, extensive formula in order to solve for x-intercepts. But here's a way that we get around that in order to know that our vertex was going through 7, 6.5. And here's how we do that. Very simply, I know that every parabola can be written in a standard form, such as this. Y is equal to ax squared plus bx plus c. If we remember back from the quadratic formula, both all of a, b, and c are just the coefficients that we could substitute in and allow us to solve for these x-intercepts. Well, I already know that I have these two already set up. I'm trying to find the leading term up here that goes in front of my x squared. So here's how I do that. I'm going to use my original binomials from which I work backwards from the actual x-intercepts. And I'm going to I need to find that term a. Well, when I FOIL this, I end up getting this over here. I end up getting that ax squared plus bx plus c. But I need to figure out what that leading coefficient is. The way I do that is I actually use this vertex as my clue, because the vertex has both an x and a y value. And here's how I'm going to set it up. When I come over, I'm going to actually set it up as y is equal to a times the quantity x minus 2 times the quantity x minus 12. And for these values of x and y, I'm going to substitute. I'm going to substitute in my vertex. So for the y value, we're going to take the 6.5 and substitute that in for y. Remember, we're trying to solve for a here. We don't know what that leading coefficient is. So that's going to stay the same. And then lastly, in for x, I'm going to substitute in is 7. So I have a 7 minus 2 times a 7 minus 12. And now it is an evaluation. Now all we have to do is calculate what's going to happen in this little equation here. So the 6.5 is not going to change because that was my y value. It's equal to a times, obviously, 5 times a negative 5. From there, we evaluate further. We get a 6.5 is equal to negative 25a, and then divide both sides by negative 25, obviously. Now I'm going to pull up my graphing calculator for this, because this is something that you will be doing. And here's my graphing calculator. I turn it on, and here's my graphing calculator. When I turn this on, what I'm going to do now is I'm going to actually go to divide this 6.5 by negative 25. Oh, hit the wrong button. And I get this decimal here. This is actually my answer for my value of a. Now, if it actually gets an end, if it ends like negative 0.26, that is okay to use for my coefficient a because it's not repeating. It's not going over and over again. It's not like a fraction like 1/3. If it is a fraction, if it happens to be a fraction that you don't know and you can work with, the simple way to obviously do this is to take this answer, go from math, transfer it into a fraction. I get a negative 13/50. We could use either in this case. I think it is easier for the time being, because we're going to substitute this back into a program, I think it's easier to use this negative 0.26. So that's what I'm going to write down. I'm going to have this as a negative 0.26. And that is the leading variable, or the leading coefficient of my parabola. So the way this works is, I'm going to take my original equation, and just like we were, imagine that we were factoring out a greatest common factor, I'm going to have that negative 0.26 on the outside of my trinomial, and on the inside is the original that I had right here. Which my last portion, all I need to do now is I need to distribute this back in to everything in here, which I'm going to do. And when I do that accurately, our final equation, or my final equation, gives me this. A negative 0.26x squared plus 3.64 x minus 6.24. The nice thing about this then is I can type this literally into GeoGebra, which I'm going to do right now. So finally, ladies and gentlemen, here is GeoGebra. I'm going to take my equation, which was y equals negative 0.26x. I have to use the caret for the squared button, plus 3.64 x, and then minus 6.24. And if I did that correctly, when I hit enter, this line will go directly through all 3 points. And it does. And this is your final parabola project. For the rest of this, I will help you design these lines, how to make them a different color, etc., how to make them wider, smaller, dotted, and we will work from there.